Before I get into the meat and bones of talking about Swerve, let me just quickly vent about stupid screen recorders. Bro, I tried like, I want to say 3 different screen recorders, and it's just like really annoying quality, and then audio and stuff. So, you know, I tried screen recording, but recording with my phone is like a billion times easier. So, you know, if you have any suggestions, please comment. But this will work out. May I introduce to you FTC Swerve, rare of its kind. Here is just like a small pot of it. This is a very bad example of Swerve. Many other teams have created better versions of Swerve, and I'm gonna explain why this isn't that good. From basic looks, if you've seen other Swerve pods or anything, you can already start seeing a lot of things are very messy. Let me start explaining it. If you're here, you probably already know what Swerve is. But for the few people who don't know, it's basically just this wheel that spins, but also it can rotate around like this. It's like one of those wheels on a shopping cart, essentially, but controlled with motors and stuff. And it's technically a more efficient wheel design that would be better for robots. But it is extremely complicated, and for the sake of FTC is like never done because it's so complicated, and Mechanism is just typically superior, and it's just basically the more optimized version for FTC. But it is used in FRC for because it's bigger and whatever. I'm not a FRC guy, so somebody else can explain that. So let's start talking numbers. Well, okay, first we're using an Axon Mini here to control the position of the pod. Axon Mini is just really compact, and Axons in general just provide a lot of strength and are pretty reliable. And then we have Go Build freaking without the gears and stuff, without the gearbox motor, which is like roughly 6,000 RPM, which then we gotta gear it down from, God, it's been a while. 20 to 60 tooth reduction to then, which goes down through a shaft in between here, which also is another 2 to, wait a minute, low key, let's double check how many teeth this one is. Nope, that's 40. Sorry, I lied. That's 20 tooth to 40 tooth reduction. So like halving it. And then we half it again with bevel gears here for that speed to get to the wheel. So that, in addition with 66 millimeter wheel-ish, maybe like 59, so like 60s, right? Millimeter wheel, it would provide roughly the same speed as regular, well, not regular, like of course gearing it a bit for like the optimized RPM for FTC. So somewhere like 500. Yo, I'm low-key retired. I don't even know numbers that well. But actually there's no but. Next, we have this grip tape, which with the 3D printed wheel inner core, we put grip tape on here to have like these custom wheels that are just super grippy, and you will not have like actual good wheels on the market. Actually, you could find decent wheels, but if you're doing Swerve, you're probably already doing everything custom. In addition with that, this is 3D printed, that's 3D printed, everything's 3D printed except this bearing, that, and whatever parts look like they're from GoBuilder. So you know, these beams, bird, chill out. But I tried making a pattern for it to follow more of the GoBuilder system, but that didn't turn out as organized as I wanted. And for the robot I built last season, I did actually try out this Swerve. In a moment I'll get into why everything worked out, well, it didn't work out and it was super poor. But here I use these to create little walls and barriers, whatever, and connectors. So basically you can just connect, I don't know, like a U channel in between this and the next pod. Some other worthy things of noting. Oh, it's not in this CAD, but there is just shorter cap for this that I used in the design just to save those extra millimeters and make sure it doesn't scrape against the floor. You can just find it anywhere, probably in Bamboo, Handy, whatever. The Bamboo 3D model space, you can probably find the shorter cap of that. Of course, the servo is 1-to-1 to the pod for accurate thingy. Here it kind of looks like this would interfere with the belt, but I ended up using a different rod, and this is obviously cut out of aluminum. And then we have the bearings everywhere to make it as little friction as possible, because it is very, very important to have this running as smoothly as possible, because 6,000 RPM has zero torque. Even if there's a bit of friction, that can cause a big difference, which is kind of why it did not end up working out for me. Time to talk about where it went wrong. Another thing I want to mention before that though is I ended up in my final design kind of like merging this plate with the same plate on the other side for just structural integrity. It was just basically mirrored on the other side, and that'd be like the left side of the chassis, and then you just take this, flip it around, that'd be the right side of the chassis. Bada boom, bada bang, you have a chassis. You have Swerve. But if it was only that easy. One, coding is a whole different issue, and I thankfully wasn't the one that had to go through the trauma of at least trying to code Swerve. So that I can't tell you much about except from the minor details I know. But first, mechanical. This is close. You know, this is like an alien trying to clone what a person is, but being like almost there. This is like pretty close mechanically. Like there's some things that are just kind of annoying, like this top plate. It does not go well with traditional GoBuilder, you know, holes, whatever. But it's like, you know, preferences. It's not, you can work around it, I guess. But the bad part was the connection between this, that, in between here, having this gear. Actually, it was mostly between this bevel gear and this gear here, causing a lot of wobbling, and this kind of like relative gear chain here caused like a lot of friction, and also the gear here and the rod that goes in between here caused a bit of friction and made it kind of harder for it to actually get the acceleration it needed. And again, this is just such a slow RPM, and 0 torque. It's such a fast RPM, I'm so sorry, that and 0 torque, that small stuff can really create a big difference, and you really have to make sure there's like 0 friction, which it's really hard to do when there's so many different pulleys, gears, stuff it's running between. It's really hard to optimize that unless you have freaking grease everywhere. Like I actually don't know how it should have been optimized that much, except for like minor things with like spacing or whatever. But that was the main problem mechanically. Coding wise, getting the axon to have the proper positioning of the pod was very, very difficult from what I heard, from what I had my coder explain. Essentially, having the axon also turn a whole pod, a fourth of the robot, was also like a lot of power and hard for a tiny axon mini to do, which, you know, others have done. So it's more so, I don't know, either mechanically it's bad or something coding wise. It could be both. Don't quote me on it though. But keep in mind, coding Swerve is incredibly hard, and you'll forget about freaking having auto for Swerve. That's another. Don't no. But this is from what I learned about Swerve. Maybe this will help someone out there. Boom, Swerve. Alright, bye bye, have a good one.